Solving systems of equations by substitution. Consider the system of equations x plus 2y equals 4 and 3x plus 3y equals 10. A note: if you have two unknowns, in this case x and y, you need two equations or two pieces of information to solve. If you have three unknowns, you need three pieces of information. So when we solve by substitution, one very good way of doing this is to take one of the equations and solve for it in terms of one of the variables. In this case, I'll say x equals negative 2 y plus 4, like that. And then I can take this x and substitute it into the x in the other equation. And when you substitute things, unless you're 100% certain you don't need to, substitute inside parentheses. So I recommend just always substitute inside parentheses. So I get 3, and instead of writing x, I can write in parentheses negative 2y plus 4. Then I can put the rest of the equation plus 3y equals 10. And now I have a system of one equation. It's not really a system. I have one equation and one variable. That's what I want to have. So we just do the algebra that we know. In this case, I'll distribute the 3, giving me negative 6y plus 12 plus 3y equals 10. And then negative 3y equals negative 2, or y equals 2/3. And once I know the value of y, I can go back and substitute into any of the equations to solve for x. Since I already have x alone right here, I'll just substitute my y in there. So I have x equals negative 2, but instead of y, I'm going to put 2/3. Notice that I put inside parentheses, out of habit, plus 4. And then I could simplify this. X equals negative 4/3 plus 4, but 4 is 12/3. And then I'll put the answer down here. X equals 8/3. Let's do another kind of straightforward example. Let's say x minus y equals 3. And we have, say, 2x plus y equals maybe 12. Let's try that. All right, I will solve for y this time. I'll use this top one. I get x plus 3. Nope, I get x minus 3 equals y. I got to move the 3 over to the left and the y to the right. And then I can substitute this y down here. Give me 2x plus, and out of habit, I'm going to substitute inside parentheses, x minus 3, just to get my mindset that way, equals 12. Now, I didn't really need the parentheses here, but as I said, out of habit and also to get you used to doing that, I put in parentheses. So now I have 3x and then minus 3, but I'll add that to the other side. So I get 3x equals 15, or x equals 5. And I can solve for y by plugging in here or anywhere really, and I get y equals x, but x is 5, minus 3, so y is 2. All right, let's do one more. How about this one? X minus y equals 3. Y plus z equals negative 2. And x minus z equals negative 3. Now, there are different ways to solve. You can guess and check. We can eliminate, but we're practicing substitution here. So do you have an idea of what you could do? Well, let me see. I can choose any variable that I want, but let's see if I can get rid of my y's and my z's and have only x's. How would I do that? Well, let's look at this first one. And I'm going to solve for y. And it's just like we had above, x minus 3 equals y. And then I'm going to solve this bottom one for z. And if I do that, I get x plus 3 equals z. Now, can you see why I thought to do that? It's not the only way. It might not even be the best way. It's just what I happen to see. And even if you didn't think that we should do that, do you see how it benefits me now? If you're not sure, look at this equation I haven't used yet. What if I let y equal x minus 3, and then z equals x plus 3, and I substitute into that equation like that, using the information that I solved for in the first and third equations. And then, of course, that equals negative 2, right there. And now I have an equation with only one variable, which says 2x minus 3 plus 3, or 0, equals negative 2, which gives me x equals negative 1. Can I easily solve for y and z? Of course. Y equals x, but x is negative 1 minus 3, or negative 4. Z equals x plus 3, but x is negative 1 plus 3 equals 2. And I get the solution negative 1, negative 4, and 2. X, y, and z.